Determination of surface tension of a given liquid by stalagometer. Aim: to determine the surface tension of the given liquid by stalagometer, that is through drop weight method. The objective of this practical is to study the method of determining the surface tension of a liquid and to study the mechanism and the kinetics of flow of liquid. By knowing the surface tension of a material, one can understand the ability of the object to float on surface of any liquid and also can understand the shape of interface between two immiscible liquid. Surface tension of a liquid. Surface tension is a property of liquid surface displayed by its acting as if it were a stretched elastic membrane. This phenomenon can be observed in the nearly spherical shape of small drops of liquid and of soap bubbles. The surface tension is responsible for the curvature of the surfaces of air and liquid. The surface tension is responsible for the ability of some solid object to float on the surface of the liquid. Hence, in this diagram, we can see that the surface tension is a property to reduce the surface area as the molecules are attracted towards each other because of the presence of cohesive force. Hence, for any liquid, when it falls, it is in the form of spherical shape. The surface tension of water creates a necessary wall tension to form the bubbles of water. This tendency to minimize that wall tension pulls the bubbles into spherical shapes. Surface tension depends mainly upon the forces of attraction between the particles within the given liquid and also upon the gas, solid or liquid in contact with it. The formula for finding the surface tension is T is equal to F upon L, where T is the tension on the liquid, F is the force per unit length and L in which the force acts. When a liquid is allowed to flow through a capillary tube, a drop is formed at its lower end, which increases to certain size and then falls off. The size of the drop depends on the radius of the capillary tube in the stalagometer and the surface tension of the liquid. The surface tension acting along the circumference of the capillary tube supports the drop in upward direction. Hence, the measurement of surface tension of liquid is based on the fact that the drop of the liquid at lower end of capillary falls down when weight of drop becomes just equal to the surface tension. The factors affecting surface tension of the liquid are: the surface tension depends upon the nature of the liquid, the surrounding environment and the temperature, the liquid, the type of liquid where molecules have larger attractive intermolecular force which will have a large surface tension. There are several methods of surface tension measurement. Capillary rise methods, stalagometer method, that is drop weight method, Wilhelmli plate or ring method, maximum bulk pressure method, methods analyzing shape of hanging liquid drop or gas bubble, and the dynamic method. For determination of surface tension of any liquid, the number of drops produced from equal volume of two liquids and their density must be known. This is the stalagometer and here is the capillary tube. Knowing the surface tension of the reference liquid, that is water, the surface tension of the given liquid can be determined. As we can see, the drop of the liquid gives the weight of the drop and when the surface tension acts along the circumference of the capillary tube. The materials required for the experiment are stalagometer, beaker, stopwatch, sucker or rubber bulb, pipette, digital balance to weigh the density, hot air gun to dry the apparatus. The chemical required are chromic acid to clean the apparatus, acetone to dry the apparatus, toluene, water. We can also find the surface tension of another liquid using xylene. Determination of surface tension by stalagometer. The stalagmometric method is one of the most common methods used for the surface tension determination. The several drops of the liquid leaked out of the glass capillary of the stalagometer and then weighed. If the weight of each drop of the liquid is known, we can also count the number of drops which leaked out to determine the surface tension. The drops are formed slowly at the tip of the glass capillary placed in a vertical direction. The pendant drop at the tip starts to detach. This is the pendant drop at the tip start to detach when its weight, that is volume, reaches the magnitude balancing the surface tension of the liquid. The weight, that is the volume of the liquid, is dependent on the characteristics of the liquid, that is the viscosity of the liquid. Effect of temperature and impurity on surface tension. As the concentration of the impurity increases, the equilibrium surface tension decreases. Highly soluble impurity salt dissolve in water, surface tension of water increases. Insoluble impurities like detergent, if present, it will decrease the surface tension of water. Hence, the surface tension of liquid decreases with the increase in temperature of the liquid. Also, the angle of contact also decreases with the increasing temperature of the liquid. This is the equation to find out the relative surface tension of the given liquid with respect to standard liquid, that is water, where gamma upon gamma W is equal to N2 upon N1 into D density of liquid upon density of water, where N1 is the number of drops of liquid and N2 is the number of drops of water. Procedure: clean the stalagometer first with NaOH, then with chromic acid solution to remove oil, grease, etc. sticking on the inner capillary surface. Wash it with distilled water and finally with acetone and dry by passing air. Immerse the lower end of the stalagometer in a beaker containing distilled water. Suck the water until it rises above the mark A. Control the rate of flow of water with the help of screw. Pinch cork so that the number of drops per minute is about 15 to 20. Now let the water flow out and start counting the number of drops when the water meniscus just reaches the mark A, and counting is stopped when the water meniscus passes the lower mark B. Let the number of drop be NW. Repeat to get 3 readings. Repeat the same procedure step by step for water and also note down the reading as per the observation table. Repeat the experiment by taking the same volume of distilled water and note down the time taken T2 for the flow of water from mark X to Y. Repeat it thrice. Weigh the relative density bottle and note down its weight. Fill it with the given liquid and weigh it again. Remove the liquid, wash it with chrome acid and then distilled water and dry in the oven. Now fill it with the distilled water and weigh it. Observation table. Note down first the weight of empty specific gravity bottle, that is W1. Then after the experiment, weight the specific gravity bottle with water and weight of specific gravity bottle with liquid. So the weight of water will be getting W2 minus W1 and the weight of liquid will be getting W3 minus W1. The observation table, you have to note down the number of drops counted when the liquid flow from mark X to Y and then take the average or mean. Same way for the given liquid also, find out the number of drops. The ratio of density of unknown liquid to density of water is W2 minus W1 upon W3 minus W1. With this ratio of density of liquid and water, we can find out the relative surface tension of the liquid, that is gamma 1 upon gamma W is equal to NW upon NL into DL upon DW, that is density of liquid upon density of water. and the absolute viscosity can be find out by rearranging the terms of coefficient of surface tension of water. So the equation becomes gamma 1 is equal to NW dl gamma W upon NL dW. Hello, today we will be doing the practical of finding the surface tension of any given liquid. So our today's practical aim is to determine the surface tension of a given liquid by staligometer. That is, we will be determining the surface tension of the liquid by drop number method. The apparatus and the chemical required for the practical are: first, staligometer. This is the staligometer. Here you can see there is a bulb and there are marking. This mark is, upper mark is A and below mark is B. So first, this staligometer should be cleaned with dilute NaOH and then with chromic acid to remove all the impurities and dirt, if any, present in this particular capillary tube. Here at the bottom of the bulb, the below part contains a small thin capillary tube through which the liquid has to flow down, and we have to calculate the number of drops. The chemicals and the other apparatus required are: this is a specific gravity bottle with the help of which we will be finding the weight of the given liquid and water. We require distilled water, then the liquid whose surface tension is to be determined is toluene, and this is the acetone required to clean and dry the apparatus before the experiment. We have already cleaned the staligometer with NaOH, chromic acid, and then dried with acetone. Now let us start the practical. First we have to insert this in the liquid. The standard liquid we are taking first as water. With the help of rubber bulb, press the rubber bulb and suck the liquid above the mark A. So you can see here the liquid is coming up. Slowly the liquid is coming up. Let the liquid rise up to the mark A and then above the mark A. After taking the liquid, start the value when the water flows down from this mark A up to mark B. Per minute, 15 to 20 drops of water should flow down. So you can see here the water is flowing out, and when the water reaches up to the mark B, stop the pinch cord. Count the number of drops falling down. From mark A to mark B, you have to count the number of drops. Now the water is coming up to the mark B. Okay, now stop counting the number of drops and take this specific gravity bottle to weigh the liquid present in the amount of liquid present in the gravity bottle. Now we have to take the weight of this liquid present in the gravity bottle which we have taken, that the amount of liquid from mark A to mark B, and we have the value of the number of drops from mark A to mark B.